Bart's your next speaker. He's going to be talking about 9 features that will shape the future of SCADA systems. And just so you know, and Bart has this in his outline here, but Bart used to be an operator. Now he's an engineer. So Bart, he works for MPE Engineering Limited. He's a control system specialist and Vancouver Island regional manager for MPE Engineering. He values the early days of his career, which we just talked about actually. And when he just started out as a plant operator and has a background that has provided him with the experience like no other when building control systems. These days, Bart coordinates projects, helps municipalities bridge the gap between operational technology and information systems, writes proposals, teaches courses, designs secure SCADA system environments, and still does a little bit of programming if he really, really has to. Can we welcome Bart to the stage here?
Thanks, folks. Loud and clear. I wanted to talk a little bit about control systems and SCADA systems. One of the things I really wanted to start out with is to say that MPE engineering is vendor neutral. So we're going to talk a little bit about control systems, but really it doesn't matter what brand, what make, what model, what size. The features that I wanted to talk about today really apply to control systems that are provided by any and all vendors that are out there. And the other thing I wanted to say is that what I'm going to be talking about is my opinion. And of course, you know, we've got a bunch of control systems guys, and we always talk about some of these features, and I kind of put them together and presented it, and we'll be presenting that to you guys today. So, you know, the next person that you're going to be talking about or talking to about control systems may say that there's only 5 features or 11 features that help contribute to the future of SCADA systems, but I just came up with the 9. If you guys are interested, one of the things I also wanted to mention before we really get going is I am a certified instructor through the EOCP, and on October 12th, I will be teaching a course that covers control systems and SCADA fundamentals, and it's a 1-day virtual course for 0.6 CEUs. You can enroll through the BCWWA website, get your CEUs. And it really talks about control systems from the ground up. We start talking about the components that build up control systems. Some of the things that we're talking about today will be covered in it. But if you're interested, look it up. Having said all that, what I'm hoping to do today in the next 45 minutes or so is to educate, to provide a little bit of knowledge, to help you guys make decisions if you're going to be involved with control systems going forward. I'm a firm believer that if you're looking for a new pickup truck, that you should probably understand a little bit of some of the bells, whistles, and features and functions that are out there with various brands. And if I think about that, control systems really are not much different. So think about what kind of options there are out there. Figure out what is important to you guys. In your municipality versus other municipalities, you'll find that some of the features and functions may or may not even be important to you, but today is an effort to educate you a little bit on what's out there. Know what to look for and who to involve, because you as operators within the facilities may not end up being the people that will actually do maybe a lot of the control system work, but knowing who to involve, whether that's third parties or even internally, potentially IT type people, that can be important. And then before we get really started, I quickly wanted to cover the 4 levels of a control system, of a SCADA system, just so we're all talking about the same thing. A SCADA system is built up out of instrumentation. So that's the devices, pumps, valves, variable frequency drives, analyzers, monitors, all of that instrumentation that is sitting at the plant floor. Those devices are wired into a controller, a PLC or an RTU, and that's the second level. And that's the device that is programmed by geeks like ourselves that actually operate your plant. So that's a PLC or an RTU. And those PLCs or RTUs are communicating through some sort of a communication infrastructure. Now, that communication infrastructure can be wired, radio, cellular, satellite, you name it. It can be anything and everything. But it's that third layer, that communication layer, that plays a critical role in a SCADA system. And then the top layer, the fourth layer, is the actual interface, is where you actually see your graphics, your objects on a screen, your pumps, where you can click on it, you can press start, and you can actually control your equipment. So those four different layers make up that control system. Instrumentation, the controller, the communication, and then your SCADA interface. Now, the SCADA interface is really what we're going to be talking about today. So the features that we're going to be covering are the ones that are associated with the interface you look at, and how that how that works, and how that is going to be shaping the future of what we're going to be working with. So the first one, ease of configuration. So what we're looking for in future SCADA systems is something that can be deployed relatively quickly, which obviously keeps the cost down of the configuration, building the graphics. And in order to build the graphics, to put a pump object on a screen, you want that pump object to be we call it a symbol, that being a template, that being an object that you can just drag, drop it on a screen, and then you animate it. And then when you animate it, it represents the running or stopped status. So if you have these symbols available, your configuration time will certainly be a lot less compared to having to build these symbols from scratch. Now, I put a note beside symbols saying that it's important to have symbols that are applicable to your industry. I mean, there are SCADA systems that are very focused on oil and gas, for example, because supposedly oil and gas is where the big money is. Well, that's all nice and dandy. But if you are in a different industry, you want to see if you can engage with a SCADA software package that has symbols that are applicable for your industry. Makes sense, right? Then I put communication protocols on there. A protocol, you can see that as the language of devices within your control system. So between your PLC and your SCADA system. And different vendors, different suppliers have different protocols. So what you're looking for is a SCADA system that is capable of communicating to pretty much every controller that's out there, and have the communication drivers, we call them, available. Revision tracking. That's a feature that some SCADA systems have, where if you do development and you make changes, that you can revert back if your changes are not the way you expected them. And it's history tracking, I think, in things like Word or Excel, right? Where if you have your, on the top in the center nowadays in Word or Excel, you can go back to previous versions when you saved your document. And SCADA systems have that feature nowadays, and it can be really valuable. For example, backups. If you get hacked, if something was broken, you can simply, very quickly, revert back to the version of the known software that you know worked and deploy that again. And then the last one I put on this slide for the ease of configuration is you want some software that is easily supported. Now, I put two bullets underneath it, one for the developer. So that's the company that actually programs your SCADA system from scratch. And that's important, that they can support your control system and your software. But at the same time, you also want to make sure that you have SCADA software that can be maintained by anybody, because your maintenance may not be done by the same company that actually built your SCADA system when it was new. Or after a few years, you may end up, through a municipality, have to put your support out to tender, and you may end up with a different company. So you want to make sure that you have SCADA software out there that is easily supported. Second feature, scalability. So what do we mean by that? Well, there's different types of of SCADA software and adding features onto it. We call that being modular. So for example, you can have a module for alarm-related functions. So if you're not necessarily looking for, let's say, callouts, because maybe your facility is manned 24/7, you may not want the module that creates alarm or enables alarm callouts. You want to make sure that if you expand sites or add sites to your SCADA system or to your operation, that they can be easily represented within your control system. For example, remote access may not necessarily be part of the SCADA system, but it may be a module that you add on to. So you purchase that if you need that. So that's the idea behind scalability. And the idea with that is that, of course, you can start out small and you can add on to it. You may end up purchasing another feature or another little license or an expansion to a license, but you can grow your SCADA system as needed. Virtual machine. Now, that's a more of an IT type term, and a virtual machine is actually where you can run multiple instances of an operating system on one computer. Now, the computer has to be beefed up, but the advantage of that is that you have less hardware. You have less hardware to worry about and maintain, and you can run multiple instances of an operating system on that one server. And this is very beneficial, once again, because you have less hardware to worry about and maintain. So it's very cost effective. And what I'm saying is that if you're looking for a control system, the shape of SCADA systems going into the future is that they need to be able to support a virtual environment. And not all of them do right now. Related, cloud-based technology. We're doing a lot of stuff on the cloud, I think, in general, but I believe that a SCADA system needs to be enabled and be cloud-based ready. So what would that mean? That really means is that you in your plant will no longer have an actual server sitting on your desk. That when you run your facility, your actual operating system is sitting out on the cloud somewhere. Might be a bit of a scary thought, but at the same time, like I said, we're doing a lot of stuff in general on the cloud already. So control systems are going to go there. Redundancy falls under scalability. Now, I'm going to cover redundancy in a few more features in feature number 6. So we're not going to spend a lot of time talking about it right now, but the redundancy certainly would have to fit under scalability to be able to provide one SCADA server with a backup in case your primary or your one SCADA server fails. And then licensing. Typically, most SCADA systems are purchased through a tag-based licensing scheme. So what that means is that you purchase a license for a number of devices that your SCADA system can communicate to. And at some point, if you exceed that number of licenses or you creep up to maximizing the number of points that you're actually communicating to, your valve, your pump, your motor, all of those things, that you can expand on that tag license, and you can simply purchase a larger license to the point where you're now running 10,000 points, 20,000 points. We have seen SCADA systems with 1 million points. That's huge, not in the municipal business, but the idea behind scalability is to be able to purchase your licenses and grow them as you need to. Feature number 3, IoT ready. Show of hands. Who is familiar with the terminology IoT or Internet of Things? Right on. For those that are not familiar with it, let me explain. The Internet of Things, by the way, I think it's a ridiculous acronym, IoT, but that's beside the point. The definition of the Internet of Things is it describes the exchange of real-time data over the internet. I'll repeat that. Real-time data over the internet. I'll give you some examples. Let me see how many steps I took today. Your Fitbit. That's an IoT device. Hang on. Somebody is just at my door. Let me see who it is. That's an IoT device. Your Tesla. Your Find My iPhone. I want to see where my daughter is hanging out. Your thermostat at home. Hey, I'm going to be home in 20 minutes. I'm just going to turn the temperature up now so it's nice and comfortable when I get home. All of those are IoT devices. Your blood sugar level monitor for those with diabetes. I mean, your Google Home. Hey, Google, play me this song. Your smart appliance that will start beeping or connect to your phone when your fridge is below or higher than a certain temperature. All of those are IoT devices. And I think that when I explain things this way, and if I ask this question again, who knows or understands what IoT means, that more of you are going to say, hey, yeah, I get it now. I get it. We use all of these devices all the time because we do. That's what IoT is all about. So we're starting to see IoT in the world of process control. And guess what? We've added a letter to that three-letter acronym. We're now calling it the Industrial Internet of Things, IIoT. In my humble opinion, again, just about as dumb as the first one, but that's beside the point. So what we're doing, and I'll give you an example, we are using this type of technology to provide a real-time monitoring, and we've done this for a few of our clients where we have no communication infrastructure, we have no power, but there's a reservoir sitting out there somewhere. So the client obviously needed to monitor that reservoir, and the best solution that we could come up with was a little IoT device. And that IoT device is powering up a level transmitter. It is taking a reading of that transmitter, and it's sending that to the cloud. And then the SCADA system is fetching that data as needed and displaying that on a process graphic and representing that in an object that represents that reservoir. So that's an example of an IoT device in the world of process control, and it's out there. The beauty of an IoT device, or just like any other communication infrastructure in the world of SCADA, is that you can mix and match all of these communication type layers and protocols. Remember, we talked about that just now. You can mix and match all of those. And for an operator, it looks all the same. One reservoir that is using this IoT type functionality versus one that is hardwired versus one that is communicating through satellites and one through pigeons for all I care. It all looks the same on a process graphic. Protocols, mentioned it already, BACnet. I threw that one on there because those who are in the building control system type world, and I've spoken with a couple of people here in the last day and a half, the equipment that controls buildings have always had its own proprietary protocol called BACnet. And BACnet has always been very separate from the world of process control, the way that most operators in this room know it. Nowadays, what I'm saying is that SCADA systems in the future should support protocols like BACnet. We should be able to integrate building management, building control type stuff into your process control and mix and match. We are there. Not every SCADA system supports it right now, but I think it's important. And then I put two other protocols on the screen. One is OPC, and that's a standard for communicating that has been out there for about 20 some years. And then this MQTT thing. And MQTT is actually the protocol that is used by IoT devices. So this little level monitoring device that I briefly explained is using this protocol called MQTT. Why am I throwing it out there? Because maybe at some point you're going to hear about it. And if you are involved, with SCADA systems or a selection or an upgrade of a SCADA system, ask your vendor, are you MQTT ready? That's a question that I think you might want to park and think about. And as far as integration is concerned, modern SCADA systems that are ready for the future should be able to embed things like video, should be able to embed things like web-based data. So for example, integrate your temperature, integrate your weather, integrate your river heights, integrate some flow, integrate data that is sitting on somebody's website somewhere and bring that into your control system. Integration. OT with IT. Now, what is OT? I think we all understand the world of IT, information technology, the guys that look after your computer, your email, your Microsoft Word. OT stands for operational technology. Operational technology. And it includes, the definition is that it includes using hardware and software for your process control. So it includes more than just a PLC or the program. It also includes the process. It includes your procedures. It includes your SOPs, things like that. That's all part of operational technology. And this is feature number 4. It's important to have a SCADA system that is ready to integrate with the world of IT. The reason we do that, the reason we need that is because the world of operational technology and the world of IT, integration technology, they're starting to blend together. We are using features and experience and knowledge from the world of IT, and we're starting to use that within the world of operational technology. For example, not only hardware but software. For example, authentication, alarms, user credentials, because we have within the world of IT a process of, for example, setting up an email address and things that come with hiring a new recruit. And there's no reason that a control system within the world of OT has to have a separate account that somebody types in the name and user and the credentials for that new operator. We can blend those worlds together so that if an operator leaves your municipality, that those credentials are automatically removed without out from your control system. So the world of the two are blending together, and it's important that your new SCADA system or the features of a SCADA system are ready for that integration. I put segregated networks on there because obviously now we're starting to talk about the world of, related to cybersecurity. We're going to talk a little bit more about that. That's one of the features coming right up. Before we move on, I wanted to highlight that there is a significant difference in the world of IT and the world of OT in terms of priorities. As operators, we need a SCADA system to be available. Availability is priority number 1 for SCADA systems, for control systems. In the world of IT, confidentiality is priority number 1. Keeping data and access secure. And confidentiality and availability don't always play together nicely. And that's where some challenges come up when you start talking about bringing the worlds of OT and the world of IT together. So now you may say, well, why then are we actually doing that? Well, once again, because we are leveraging some knowledge that we collectively have learned and gained in the world of IT. If we do so, we are reducing operating costs because IT guys are very good at certain aspects of network, of access, segregation that we can benefit from. And we are blending things together. We want remote access. We want to be able to have a look when an alarm comes in to see what our process is doing. And we are using some IT type functionality to do that. Feature number 5, data management. Now, I don't think it's a surprise that nowadays we have more data available than we did a year ago. And if we're following this trend, we will have more data available to us a year from now than we have today. And we need to manage that. We need to be able to analyze data and pick out what's important for those who need certain pieces and bits of information. So that's where the analytics come in. To have a lot of data from your process that, levels or pressures or temperatures and flows, to have all of that data being pulled every so many seconds and all sitting in one big bucket that continues to grow is useful, but it only is so useful because there might just be an overload of data. We need to be able to create a proper visualized type tool through dashboards or some sort of reports or trends that provide access to the data that is needed to different teams and divisions within your organization. So we have operators, but we have different information that needs to be accessible to people in maintenance. Different information, again, needs to be provided to management, et cetera, et cetera. Your engineering team might want completely different data yet again. All of that is sitting within that massive bucket of data that is constantly growing. But in order to pick out the right pieces, we need to just simply manage that. So SCADA systems are being equipped nowadays with the visualization and the dashboard type tools that allow access to that data in a user-friendly method to be able to extract the data that is necessary by different audiences. So dashboards or visualization, definitely something that future SCADA systems need to incorporate. In the past, SCADA systems were almost proprietary. One SCADA system would log data in its own historical files, and only that particular SCADA system would be able to access the data sitting in that file. And we need now SCADA systems that are capable of storing data in an open format, that different software solutions within your organization have access to that data. So no more proprietary. Current and a feature of SCADA systems needs to be that it's an open database type format. Artificial intelligence, machine learning. We've heard this term a lot. And I wanted to zone in just briefly about what this really means and what it is. SCADA systems can learn behavior, and machine learning is a branch of artificial intelligence, AI. It is focusing on data, and it takes that data and uses algorithms to imitate human behavior and to learn and gradually improve accuracy and efficiency. That's what machine learning is all about. And this can be done through SCADA systems of the future. I didn't want to spend too much time on it, but that will become a bigger thing over time. At this time, SCADA systems aren't quite there yet, but it's coming. Feature number 6, accessibility. Now, we briefly mentioned already remote access. There's huge benefits to being able to remotely connect to your process control system and see what's going on in your facility. There's a couple different ways that remote access can be provided. One, and I've already whipped out my phone and said, here, we should be able to connect to your SCADA system, right? On a mobile device versus a website that can be accessed, or both. And many SCADA systems support both of these ways of remotely accessing their control system. Earlier on, we mentioned redundancy briefly, and I wanted to dive into this a little bit because I think it falls under access, to make sure that when you have a primary SCADA server, that SCADA server is backed up and you have a redundant backup. Maybe you have a triple redundancy and you have a third server sitting somewhere. What's important in redundancy is that if your primary server fails, that your backup automatically steps up to the plate to take over the functionality of your primary server. So we call that automatic failover. It does not require somebody to physically, for example, move stuff over, whether it's moving a cable over or pressing a button. It should automatically fail over. Distributed redundancy means that your primary server that may be sitting at, let's say, your water treatment plant is backed up by a backup server that might sit in your public yard office or in your city hall or in your boss's basement or maybe in the cloud. The point is that your redundant server does not have to sit right beside your primary server, which is a huge advantage in case of a serious issue at the water treatment plant, if there's a fire or something like that, right? Now, I mentioned here full redundancy, and I said that because some SCADA systems are good at failing over and picking up the communication to your remote sites, to your lift stations, to a reservoir, and displaying that on a backup server. But does that backup server enable callouts? And if you open up a trend on your backup server after it has taken over the functionality, is all your historical data there? That's what I mean by full redundancy, to make sure that your data collection is mirrored and copied and stored in two places, really, on your main server as well as your backup server, and that your alarms are creating a call out, whether your primary is active or whether your backup is active. Load balancing. There's a feature that comes with a redundant setup, and it's really intended to say that if your SCADA server has a processor that is constantly working hard to try and get data from your remote sites, and it's busy and it's almost pinned to the max, well, maybe your backup server should actually take over some of those tasks because it's sitting there, it's helping, but why not have it help collect data, process some of that data, and share the load of what you're asking your control system to do? And that's a feature that not every SCADA system is capable of providing, but it's going to be more and more important in the future. Cybersecurity, mentioned it already briefly, but it does fall under accessibility in a way, but here we go. And it's becoming a bigger and bigger thing, right? So what is cybersecurity? I mean, we've all heard this thing, we've all heard viruses, and really, cybersecurity means that you are protecting from attacks, from intrusion, somebody trying to access, somebody trying to put malware or a virus onto your computer. And most common malware is ransomware. And the definition of ransomware is that your access is limited and restricted based on some graphic that comes up on your screen, and you are being told to put so many dollars in iTunes cards on some account somewhere in Barbados, and then you'll supposedly get access to your computer again. By the way, the statistics are not very promising at all. I think it's about 4% of those who actually pay get access again, but that's a whole different story. Really, what we're trying to do is you need to make sure that your control system is as secure as possible to fight off attacks from the outside world, and sometimes from the inside world even, to keep it secure. Now, how do we do that? There's a couple of things, we'll get to that at the end of this slide, but we use a lot of IT type technology to do so. Because our world of IT, you've all probably seen emails come out from your IT support team that says, watch out, this is a virus, or don't click on this email, or there's this particular threat going around. things like that. IT has worked and covered cybersecurity for a long time already, and I think that SCADA systems are starting to catch up. So what I'm saying is that if you're looking at a feature of a SCADA system, we should be able to connect with the world of IT and provide some SCADA security. What should it do? We need to be able to put your control system on a completely separate network from your corporate network. Now, that's an interesting point, because if you have a network that is separate for your process control, you still have to have some level of connectivity to get your data to, for example, your managers, right? Or when we talked earlier about a distributed redundancy, and you have a backup server sitting in your public yard and your primary server sitting at your water treatment plant, how do you do that? Because segregated networks really means that they are not connected, and yet here I am saying that we are connected. So IT has straddled and worked those different networks for a long time. We can leverage off of them. There are systems out there that keep separate networks connected, yet secure. Now, there's a couple of things that I put on the slide here that can be done within control systems by potentially operators or service providers that can seriously be considered to mitigate the risk of cybersecurity, one of which is regular backups. I encourage you guys to make sure that your control system is backed up, not only the application, your programs, but also your data, so that if you ever have to restore your control system, that you can do so and still have the historical data available to you. One of the things that is important to do, and I've touched on this briefly, is the user credentials. User credentials are one of the worst culprits when it comes to cybersecurity or breaching that, is to have old credentials still lingering within your control system from some operator that used to work here 10 plus years ago, and he had a really weak password, 123, right? Terrible. So keep your user credentials current. Antivirus software. It's critical to have antivirus software running on your control system. And that might be something that you might need help with. There's people that can help you with that to make sure that the software is supported and that it does not negatively impact the operation of your control system. And once you have software, antivirus type software running, make sure that you keep that updated, because we all know that in the world of Windows, how often you have to do an update. It's sometimes even doing so by itself. Your control system, if you have antivirus software, also needs to be updated and patched. So I would recommend a process every month, every 3 months, to actually go through the patches and deploy those updates. And then there's technology that we've used in the world of IT, and I've put one up here that's called a virtual private network, a VPN. And some of you might be familiar with that if you do have remote access to your control system, that you first have to enable a VPN. Now, what is that? For those who don't know, a VPN is a dedicated encrypted connection between 2 points on the internet that cannot be penetrated by anybody else. So you create from your phone to your SCADA system a dedicated connection between the two, and that is secure. Then there's technologies such as firewalls that allow a full block of unauthorized access into a network, which could be your control system, right? And a firewall is often pictured as a brick wall. And then what we sometimes have to do is take one brick out to allow a certain protocol, remember protocol? To allow a certain protocol to communicate from your SCADA system to your controller. The last item that I wanted to explain a little bit and jump into is inventory. Because if anybody in this room is saying, okay, cybersecurity, we should probably step up our game a little bit, the first thing that I would recommend that gets done within your municipality is to have an inventory. If you are looking for somebody to help you out with some cybersecurity type efforts, the first thing that is necessary is to know what you have. And only you guys know what you have. So you guys can start with an inventory. Alarm management. One feature of SCADA systems is alarm management. Now, the whole vision of alarm management is to make sure that alarms, when they come up, actually mean something. A lot of times what you'll find is that one alarm triggers a sequence of events that create more alarms, and all of a sudden in your alarm summary, that list grows very fast. What's important is the first one that started that sequence. Alarm management is the type of process that almost hides all the alarms that are a result and only lists the very first one. That's the idea behind alarm management. In order to implement that, it's a bit of a process. You have to figure out what your philosophy is. What do you actually alarm on? Then you have to go through your alarms and figure out, is this meeting the philosophy? In that process, you then eliminate the ones that are, we call them bad actors, the ones that keep popping up, sometimes unnecessary. An audit is a necessary step in the alarm management process, and then the maintenance of that process. Current SCADA systems should have the functionality to text, email, text to voice, and have all of those things available as needed for operations. And the last feature I wanted to quickly mention is shelving alarms. Shelving alarms is kind of like putting a site in maintenance mode, if you will, so that no alarms are actually being broadcasted. But the beauty of shelving alarms is that it automatically expires and enables the alarms for that particular site. So you don't actually have to remember to turn the maintenance mode off, which I think we've all done at some point. I got 3 minutes. I better pony up. Augmented reality, the last one. Augmented reality versus virtual reality. What's the difference? Well, augmented reality is where you are overlapping an image in the real world. So as you see in this picture, a guy walking around with fancy goggles looks at a piece of equipment, at a pump, and he does this, and he opens up in a virtual environment in front of him the process graphic of that piece of equipment. And you can actually control your equipment by touching it on the augmented screen in front of you. Virtual reality is where you actually simulate the whole 3D experience, right? And we're not saying that. We are saying that operators should be and will be in the future walking around with the funky glasses like this guy in the picture, and that's how you will be controlling your equipment. And SCADA systems are soon going to be ready for that. Some already are. One quick one, bonus, number 10. If you're looking for a SCADA system in the future, make sure that you pick a SCADA system that has a solid track record, both the company as well as the product. And for those that have listened to me in the past, you know that I always end up with a slide like this where it says, I can handle the future of SCADA. Thank you for your time, everybody. Thank you. Here. Oh, I thought we didn't have time for that.
Too bad. Thank you for your presentation. I just have a question regarding, you mentioned that IT and OT having different priorities and needs. And after 5 years of developing our SCADA program for our multiple sites, we're running into one of those different issues. And I'm wondering if you have any suggestions on it. Where we're at now is IT is constantly updating to patch all of their software, because it's all moving so fast.
Yep.
But our actual equipment, the HMIs, are put in place to be running, 10 years before having to replace. And they're not made to upgrade to allow for the new Microsoft Office or whatever type of software that's being updated. So they're not developing at the same speed, and we're not given the capacity to upgrade those. So we're looking at a huge cost to be able to keep up to the requirements of the IT world in order to keep operating, but it's not something that was considered in the original build. Is industry, have you heard anything about industry looking at ways to maybe look at filling that gap for operations?
To upgrade operating systems on control system components?
Yes. To a point where they only are capable of getting to a certain level.
Yeah.
And then there's no longer another step. So, for example, Microsoft
Yeah.
10, we've been able to upgrade to that point and do all the patches there.
Process control is really no different than even your version of Windows, right? At some point, your vendor is going to stop supporting that.
Mm-hmm.
And that's the reality of it. We have to accept that. And we need to make sure that whatever hardware or software you're running is still supported. So there's an end of life, there's a whole life cycle. I do cover that in that training course that I mentioned. The whole life cycle of the process control equipment, both hardware and software, absolutely needs to be taken into account. So to answer your question, I think, yes, you will at some point stop getting support from your vendor. You will no longer be able to keep current, which might trigger a replacement or an upgrade type process. Does that make sense?
Unfortunately, yes.
Yeah. Yeah.
Other questions? All right, got one.
Very early on in your presentation, you talked about SCADA systems needing to be able to run on virtual machines, and I got the impression that you were saying that that's the direction that things are moving. But then later in the presentation, there's talk about segregated networks and keeping things secure. I'm just trying to see the picture of how you can have both, like when you have virtual machines and cloud-based systems, how do you get security there? And do you actually see the industry going in that direction? What's the state of that in systems nowadays? Cloud-based.
If I heard you correctly, I think you're asking about segregated networks, virtual machines, and how to enable that.
No, I'm trying to reconcile in my mind. There's some different things that I think I heard said. So at one point early on in the discussion, I think you were saying that SCADA systems had to be able to accommodate cloud-based computing, and you saw that as the direction of the future.
Yeah.
But I have difficulty reconciling how that is going to offer the security that most owners would want to have, and most owners try to get through segregated networks. So I'm hearing like two different messages: that one, you should be planning your SCADA systems towards more cloud-based systems, but how do you do that and yet maintain security?
There are tools out there, both hardware and software, that allow for segregated networks to still be connected in a safe and secure method. I mentioned something like firewalls. I mentioned something like virtual private networks as a couple of tools that are deployed frequently to keep segregated networks connected in a cyber secure manner. And this is a world that our various IT teams have looked after for quite some time to bridge those gaps in different networks.
Okay, so that is on a network that is owner's network, owner's server, right? That's not a cloud-based server.
But it's really no different though, whether your SCADA system or your backup SCADA system is sitting in your public yard versus in the cloud. I
But when
mean,
it's sitting on a cloud, you don't really have control of it necessarily. It can be attacked from, I don't know, that the provider.
I'm sorry.
When it's on a cloud,
Yes.
does that not mean that the whole whoever is providing that cloud service is vulnerable to attack. It's no longer just in the control of the
Oh, in a way,
subscriber.
absolutely. In a way, you're right. Yeah, absolutely. So would I go with a Joe Blow cloud service? No, probably not. Absolutely. So you're right. You're going to be vulnerable or exposing yourself to your cloud service provider for some of those security type aspects. Absolutely. Yes, you are. Yeah.
So that seems like a risky, precarious situation. Do you see some clients that are actually doing that? Hosting their service, their
Yeah, we
SCADA
are.
services?
We are starting to see that. Yes. It's a relatively new development in the world of process control to have your SCADA interface and your SCADA software running on a cloud service, but we're starting to see it. Absolutely. Now, I think that privately, we have gotten used to using cloud services for quite some time. You know, we've got iClouds, we've got Dropbox, we've got all of these things that Google Drives, you name it, right? Office 365. We've used it for quite some time.
On a personal level, though. But
Right.
yeah.
But we also do our banking through cloud services. And we have slowly adapted and gotten used to that. It's now expanding into the world of process control. And I hear you in the sense that you are going to be relying on others to help you keep that infrastructure secure. Right?
Yes.
But that can be done, and that is being done. That's partially what you're already doing with an IT department. Your IT guys are the guys that you rely on to keep your email safe and to partially keep your remote access to your control system safe. That's really not a far stretch from your local IT team to the Azure IT team. So it's a slightly different way of thinking. But let's face it, you know, when we started getting used to data over the internet and started getting used to all these apps that are constantly being used by all of us over our phones. In the beginning, we were very reluctant in general, and we were not so sure about Wi-Fi and, like I said, you know, doing your personal banking online. But we've gotten used to that. And I think most of us don't really worry about that anymore because you are using your Scotiabank, your TD Bank, your RBC type infrastructure and relying on them to provide that infrastructure to be secure. We need to start thinking the same way when it comes to process control and relying on some others to help you with that infrastructure. Make sense?
It does, but it just seems like there's a big difference between an individual doing their banking and a municipality. Like every quarter or so, I hear about hacks on some server, and there's all this stuff being revealed. And
yeah, I hear you. There are hacks, absolutely, but there's also tools.
Yeah, I just want to. I did talk to you about remote sites and the difficulty in the cloud reaching those sites, because where we were from the North Island there, we don't have very good internet or reception. So how would that work from a reservoir that's 4 kilometers from any signal to where the well would be, where there's no signal either, no internet? Does that
and when you
work?
When you say signal, you mean cellular?
Yeah.
There's always satellite.
Only satellite. So the cost of that would be a SCADA system with its independent satellite as well to the tower, to the well.
It would be from a remote site through satellite to a SCADA server somewhere.
Oh, okay. So it could be like in where there is a satellite service, and then it would pinpoint to those.
Yep.
Yeah. Oh, I see.
Yep.
Okay. That makes sense.
Or radio, depending on the lay of the land. We can certainly help with doing a path profile study. If you have a couple of sites within that you operate, And if you have lats and longs, we can certainly run those through a software tool to figure out what's in the way between the two sites that you need to have communicating together. You know, there might be a mountain in the way, but if there's not, maybe a regular radio type path might do the trick. And if it's a reservoir, I mean, satellite can be expensive, but a reservoir level doesn't change that frequently. So the amount of data that you're pushing through and the number of updates that you require per hour might not be all that high. So the data that you're pushing through a satellite connection from a reservoir will be quite low.
Okay, we're going to have to cut the questions off right there, but I want to thank you all for attending this session here. And if you have additional questions, I'm sure Bart could answer them for you at a more personal level. Thank you. We'll be having the next session in just a couple minutes.